Welcome to an hour of HealthMade Radio. HealthMade is a community for natural health seekers where we educate people about common health conditions and share extensive research on the most effective natural health treatments and promote legislation that protects our health freedoms. A core concept belief is in the innate intelligence and healing power of the body, and if properly supported spiritually, emotionally, and nutritionally, it can find its way back to health. HealthMade Radio will bring information from integrative health experts throughout the world. Check us out at healthmade.co. Health is what you make it. I'm Dr. Michael Karlfeldt, and I will be your host. Today's guest is Professor Michael Hamblin. Dr. Michael Hamblin is a principal investigator at the Wellman Center for Photomedicine at Massachusetts General Hospital, an associate professor of dermatology at Harvard Medical School, and a member of the affiliated faculty of Harvard-MIT Division of Health Science and Technology. He was trained as a synthetic organic chemist and received his PhD from Trent University in England. He joined Wellman Labs in 1994. He worked initially in targeted photodynamic therapy and prepared and studied conjugates between photosensitizers and antibodies or targeted proteins and polymers of varying charge. His research interests are now broadly in the area of phototherapy for multiple diseases. One focus is the study of new photosensitizers for infections, cancer, and heart disease. A specialty of the Hamblin Lab is the development of new animal models for testing PDT approaches. The study of how photodynamic therapy can activate the host immune system to attack advanced cancer is a new direction in the Hamblin Lab. A second focus is low-level light therapy or photobiomodulation for wound healing, arthritis, traumatic brain injury, psychiatric disorders, and hair regrowth. Dr. Hamblin has published over 289 peer-reviewed articles, over 150 conference proceedings, book chapters, and international abstracts, and he holds 8 patents. He has edited the most recent and comprehensive textbook on photodynamic therapy entitled Advances in Photodynamic Therapy, Basic, Translational, and Clinical. He also co-edited a book entitled Photodynamic Inactivation of Microbial Pathogens, Medical and Environmental Applications, an authoritative and comprehensive textbook entitled Handbook of Photomedicine with 70 chapters and 800 pages, a textbook entitled Applications of Nanoscience in Photomedicine, and another comprehensive handbook called Handbook of Low-Level Laser Light Therapy is in press. 4 other textbooks are in process. He is associate editor of 7 international journals, including Photochemistry and Photobiology. Dr. Hamblin, it's such an honor to have you on the show today.
Okay, thank you very much for inviting me.
Absolutely.
Funny thing about the introductory paragraph, that one is several years out of date. But don't worry about it. I'm not going to get hung up.
What I'm curious about, I mean, you start in dermatology, and you are now you're such a focus on light therapy. Why going in that direction out of all the different directions?
Partly it was because I was working at the Wellman Center for Photomedicine, which is the world's largest research institute into how light interacts with biological systems, and specifically how it can be used in medicine, both for diagnosis and for treatment. A lot of people work in drug therapy. I mean, it's a huge multinational global industry, but as your introduction suggests, people are getting a little bit dissatisfied with big pharma pushing ever more expensive drugs at people for diseases that they didn't even know they had. And people are worried about the side effects of drugs. And light is considered to be pretty natural, actually. And the use of light as a therapy dates back thousands of years to the ancient Egyptians and traditional medicine in India and China. And it's only recently that, hard scientific investigation is being able to tease out the molecular mechanisms of how light interacts with cells, with tissues, and with whole organs. Recently, in the last few years, there's been a huge growth in LEDs. And this is important because previously people used lasers. And lasers, A, they're expensive, and B, there are safety concerns with lasers. So there are actually laser safety regulations. People have to take laser safety training courses. So this tended to put a bit of a roadblock in using light therapy in medicine. But now LEDs have really taken off. There's been a huge explosion in home use LED devices, red, near infrared, even blue, green, all sorts of affordable light devices are now on the market. And there's still some confusion, people, about which wavelength to use, type of device to use, what power density to use, how long to use it for, how often the treatment should be repeated. It's a little bit of a mind, but, light is so harmless that you almost can't go wrong. That's an exaggeration to say you can't go wrong, because you really should know what you're doing, but certainly home use light therapy devices have taken off.
So with light, then, is there, like you mentioned, it's been around for thousands of years, and they had, helio clinics where people were using sunlight to heal a number of modalities, and also in the early 1900s, I know they had in Europe, high up in the mountains, they had clinics there as well, to use light for healing. So what are the differences between the different lights? I mean, you have sunlight, you have then, like you mentioned, laser light, and then you have LED. What are the differences, or is there a difference?
There's no fundamental difference. I mean, the one issue is that sunlight has ultraviolet in it, and too much ultraviolet is clearly harmful. People who are addicted to sunbathing have wrinkled skin, they have a lot more skin cancers. So, you've got to watch out with using sunlight as a therapeutic. It turns out that if you slather on the sunscreen, you can get quite a sizable therapeutic dose of light from lying in the sun if you protect yourself from the ultraviolet. In fact, I calculated once that if you lie in the sun for 1 hour at a decent latitude in the middle of the day, your body will absorb 1 million joules of energy, which is quite a lot of energy. And this clearly has therapeutic effects. It's interesting that, as you pointed out, in the old days, the heliotherapy clinics were high up in the mountains. And that has never been explained about why sunlight is more therapeutically beneficial if you go high up in the mountains. My personal theory to explain it is that, high up, the partial pressure of oxygen in the atmosphere is significantly reduced, which means your mitochondria undergo a metabolic change away from oxidative phosphorylation to glycolysis, and it's sort of known what we call photobiomodulation. I should have introduced that the recognized term for these therapeutic uses of light has now been internationally accepted as photobiomodulation. So low-level laser therapy, low-level light therapy, low intensity, low this, that, and the other. A lot of people still use it, but it's confusing. So the field gathered together and agreed to use photobiomodulation. So having said that, why is photobiomodulation more effective high up in the mountains? I think it's because of the low partial pressure of oxygen changing the mitochondrial metabolism. But there's no hard evidence.
And it's not that you have less atmosphere that interferes between you and the sun if you're higher up.
Nothing to do. In fact, the power density is higher the higher you go.
Yeah.
But that's not it. It's definitely the organism that changes, not the light.
No. Okay. And how does, I mean, like you mentioned, we live in such a physical world where we think that, you know, in order to be able to correct something that is dysfunctional, we need to have physical therapy where we cut or we use some kind of, you know, chemical, you know, that creates a change. You know, how can light actually create a change in the body? I mean, because it's not a physical thing. It's just, you know, it's just a light. You know, so how can that impact us in health and healing?
Okay, so the first law of photobiology says that a light has to be absorbed by a molecular chromophore. This is a specific molecule, has an absorption band overlapping the wavelength of the light. And there are a number of biological chromophores in the body. The most important one is called cytochrome C oxidase, which is in the mitochondria, and that absorbs red light and certain kinds of near-infrared light. Another important chromophore, which is only recently coming to prominence, is actually water. And as you probably know, your body is 70% by weight of water, so it's massively the dominant component of the body. And it does absorb near-infrared light. And there is this concept of nanostructured water, which is water that's inside cells, and it's at the sort of interface between membrane and hydrophilic region. And this is a particular kind of water which is good at absorbing near-infrared light. So the idea is to perturb these nanostructured water layers, and this will affect tertiary protein structure and do things like open ion channels, so calcium moves around inside the cells. There are other chromophores which probably are more important at shorter wavelengths, and they're called opsins, and they're similar to the pigments in the retina that is responsible for vision, but it's just people are just starting to realize that these opsins occur in all cells. They all have the genes for opsins, and opsins generally absorb blue and green light rather than red and near-infrared. So I think those are the three important classes of chromophores. Cytochrome C oxidase is clearly the most important. Nanostructured water for longer infrared wavelengths, and going all the way out to far infrared, which is like get that in a sauna or an infrared heat lamp, and then blue or green light that activate opsins. And this is an active area of research is using opsins and further biomodulation.
Yeah. Well, we're going to take a quick break. You're listening to HealthMade Radio. I'm here with Dr. Hamblin. We're talking about new frontier of medicine, in my mind, using light for health and healing. We'll be right back. Welcome back to HealthMade Radio. You're listening to Professor Michael Hamblin, and we're discussing the new frontier of medicine, phototherapy. So, Dr. Hamblin, there's a distinction between something that was called photobiomodulation, and then there's another therapy called photodynamic therapy. So these are two different types of therapies, and what differs between the two?
Okay, so photobiomodulation uses light alone. So it relies on natural chromophores within the body to absorb the light. And the results of photobiomodulation are generally that things are healed, things are repaired, things are regenerated, or things are preserved from dying. Like a lot of degenerative diseases, you can preserve cells and tissues that are slowly dying. On the other hand, photodynamic therapy uses a chromophore, a chemical that absorbs the light, which is applied from outside. So it's a dye or a pigment. Some of these pigments are from natural sources, things like derived from chlorophyll or curcumin, which is bright yellow. They're all deeply colored dyes, right? And the idea is you put these dyes into the tissue where there's something you want to kill. It could be cancer cells you want to kill. It could be pathogenic bacteria or fungi or even unwanted tissues such as neovasculature, proliferating blood vessels. You want to kill them because they can make you go blind. And in photodynamic therapy, the artists choose the right kind of dye or pigment, how to deliver it into the right cells, the right part of the body. You can sometimes inject them intravenously or you can topically apply them. But the big difference is photodynamic therapy kills nasty things that you want to get rid of. Photobiomodulation does almost exactly the opposite. It stimulates cell proliferation, stimulates healing, and it preserves things from dying.
So for, let's say if you're just doing it for anti-aging, I mean, I would assume photobiomodulation in whichever form, whether you're doing it intravenously or you're doing it directly onto a location, let's say face or a joint, or that would be then an amazing way for anti-aging to regenerate the tissue, reduce inflammation, and so forth.
Right. And with photobiomodulation, you can either do it locally, so you can choose the part of the body that you want to direct the light to. For instance, if you have arthritis in your knee, or if you have a non-healing leg ulcer, or if you have tendinitis, or many, many local conditions. So you would shine the light beam onto the affected part. But also, photobiomodulation has a systemic effect. And this is used a lot now because people have things like whole body light pods that you climb into, or they have large LED panels that you stand in front of, and there the light is being absorbed to some degree by the whole body. And you calculate the dose in terms of joules of energy, which can be quite high. I mean, a whole body light bed can deliver 100,000 joules in 10 minutes. Definitely the effect can be systemic. So typically people have more energy, they can recover from exercise better, and they just generally feel better, actually. There's typically general health and wellness. And sometimes they don't necessarily have a disorder they're complaining of. Certainly, with athletic performance, this has become a big deal now. And if you use it as part of a training program, in other words, you do your daily training and then you shine light on the body afterwards, you find that you recover much better and that each day your athletic training progresses better. And it kind of adds up over a few weeks of a training regimen.
Absolutely. And like you mentioned, that light then impacts and the mitochondria, which is the one that produces energy within the cell, which obviously speeds up the repair of tissue and speeds up detoxification of whatever metabolic waste that we have from our activity. In addition to then, like you mentioned, it worked on that structured water within the cell, to create almost like a battery charge. It creates that separation of charge to increase electrical activity within the cell, and then also on like nitrous oxide. And
That's not right. Not electrical. I mean,
okay.
Light can't stimulate electrical activity, but it's metabolic activity. You increase the activity of the mitochondria.
Oh, okay. Yeah, I was just going with the research from Dr. Gerald Pollack and regards to using light and creating that separation of structured water. That's where I thought you were going before.
I think it increases the vibrational energy of the nanostructured water, and I think it perturbs the tertiary structure of protein. So, as you probably know, proteins have water all sort of strewn them in little pockets, and as I say, this interface between lipids and the membranes, the aqueous part of the cell. If you increase the vibrational energy, it probably perturbs protein structure.
Yeah.
And that's why I think it can open ion channels, which is a big deal. A lot of biochemical processes are regulated by ion channels.
Absolutely. I mean, you have just examples with, the chloride, ion channels, and the impact that has, and calcium, like you're saying. So, yes.
There's a bunch of ion channels that are called TRP, transient receptor potential ion channels. It's a huge family, I think, now with about 60 or 70 members. And these are basically calcium ion channels. And they're, responsible for all sorts of things, including things we're interested in, like pain and inflammation, a whole bunch of things.
And using light then directly impacts these to improve the function. So all of the, where these ion channels, the areas that they affect, the light, using the light will then obviously improve their function along with these other things that we just mentioned.
Yep, I think that's about it.
Wonderful. So it literally should be part of everyone's continual therapy to instead of trying to control disease using then pharmaceutical chemicals that we know have detrimental effect, then to add light into your life, then you can then reduce the need for these different pharmaceutical interventions and hopefully reduce also the risk for some of these big diseases that we're dealing with nowadays.
Right, and I think that it's specifically beneficial for the brain. And as you probably know, most drugs that people take for psychiatric disorders, for Alzheimer's, for Parkinson's, for traumatic brain injury and stroke, and all the things that can go wrong with the brain. Hardly any of the drugs, A, work very well, and they have huge numbers of side effects. And, millions of people are put on these drugs because they're the only thing that the physicians have to offer. And I think that the untapped potential of further biomodulation for brain disorders is just starting to emerge. It has huge benefits. Once it gets known, once people start to believe that it's real science and not some, half-baked complementary idea.
Exactly. We're going to take a quick break, and I'd like to expand on that. Very much so. We'll be right back. You're listening to Health Made Radio. I'm here with Dr. Michael Hamblin. I am Dr. Michael Karlfeldt. Welcome back to Health Made Radio. I'm Dr. Michael Karlfeldt. I am here with Professor Michael Hamblin. We're discussing light and what light can do to heal you. And I like the point that you were making in regards to half-baked science. A lot of times people think of light, kind of clump it together with this kind of new age philosophy. But in reality, there is hard science behind how it works in the body. And you were talking about how we can, an untapped areas, all these psychiatric, traumatic brain injury, Parkinson's, MS, all these different neurological and brain disorders, and we can actually use light to impact these health conditions. Is that, am I hearing you right?
Absolutely. And Alzheimer's is a huge, big deal. And in small trials, the effect of photobiomodulation has been a lot bigger than the standard drug therapy, which is Aricept, which is an acetylcholinesterase inhibitor. And in a 12-week trial, using a photobiomodulation device on the head, just twice a week, I think it was, produced, I think, a 3 times bigger benefit in terms of cognitive testing than the accepted drug therapy. So with just a small trial, and obviously there are larger trials in progress, because it's going to take quite a lot of controlled trials to convince people. But it's certainly very promising. And in Australia, they've been treating people with Parkinson's disease with similar impressive therapeutic benefits. And people are treating depression, anxiety, and post-traumatic stress disorder, and a whole bunch of psychiatric disorders. And all the preliminary results are highly encouraging.
And how is this light administered? Is it just then applied then directly on the skull? Is it intravenous? Is it, I mean, how is it administered, and what type of light is administered?
Yeah, so mostly it's a mixture of red and near infrared, with possibly a concentration of the near infrared, because that penetrates the skin and the skull better. There are various light devices that you put on your head. I mean, your forehead doesn't have any hair, so it's quite a good place to put light. And, in the frontal lobes of the brain are very important for a lot of brain functions. But some people have helmets that go over the whole head. Some people have other LED arrays that they put on. And some people even use lasers. And then they tend to move them around, because if you just stick a laser in the same place, you could burn somebody. But all sorts of devices. And even, as I say, some of these whole-body light pods are starting to show benefits to the brain.
So even if when we say whole body, does that mean that the head is inside that as well, or that you just shine the light on the rest of the body and somehow that impacts the brain as well?
Well, we think that that's the case. The head is in the pod, yes. So the head does get a bit of light, but the surface area of your head is relatively small compared to your whole body. There was a study in Australia where they were treating lower back pain with photobiomodulation, and they just noticed that people's depression got better. And when they compared the group that had photobiomodulation with the group that had physical therapy for their back pain, the people that had physical therapy, their back pain got better, but their depression did not. So apparently shining light on your back can help your brain.
Fascinating. And does it, so we're talking mostly about then the red part of the spectrum, near infrared, red. How about
anything in 800 nanometer range is good. 810, 830, 850, they're all very good wavelengths there. A lot of inexpensive LEDs are available at these wavelengths, and they use them for security floodlights by an 850 nanometer array that you use as a security floodlight, and you can buy that for very little money, and just the flat panel, you just put it on whichever part of your body you think could benefit from light.
It seems It almost seems too good to be true, because it seems, you're always used to that. If it's something that's going to create an effect, there's also a danger with it. But this seems pretty harmless and have a huge array of benefits at the same time. So going then to the photodynamic therapy, you were talking about how you would then inject a photosensitizer or into the tissue somehow, whether it's intravenously or directly localized into the area, and that photosensitizer would then absorb the light better. Is that how it works? And
it will also do different chemistry. So the idea about photodynamic therapy is that it produces singlet oxygen, which is a particular type of reactive oxygen, which is very good at killing. So if you have a localized infection using PDT, where you inject the photosensitizer into the infected area and then shining the light on it, is a very good way, A, to kill the bugs that are causing the infection, but also it kind of stimulates the healing at the same time. And often the light diffuses through the tissue, whereas the photosensitizer remains exactly where you put it, where the bacteria are.
So how does this agent, then the photosensitizer, how does it accumulate within the bacteria? Let's say I understand if you have a localized area and you can just hit it right there, but then if you're dealing with a systemic issue, let's say you're dealing with Epstein-Barr virus, or dealing with Lyme disease, or some kind of chronic systemic condition, how does the photosensitizer then accumulate and impact these infectious agents, so that when you apply the light, it then hits these agents?
Right. So, I think it gets back to the distinction between PDT and PBM. So chronic Lyme disease, I would use certifying modulation. I would not use an exogenous photosensitizer, because basically you want to stimulate the host cell. And I think that applies to most viral disorders. So I don't think PDT is particularly good at viral infections, but it's very good at bacterial and fungal infections that are localized.
So if you, because I know you're mentioning that there's some natural ones out there, and you're mentioning like curcumin, and you also have, I think there's something like St. John's wort, I think is good for...
Yeah, right?
Yeah, for kind of the yellow area, and yellow tends to be good also for viral components. So if you would have somebody ingest St. John's wort, for instance, and which is antiviral in itself, and then do intravenously yellow light, would that?
No, it would be blue light.
It would be blue light.
Yellow dyes absorb blue light. Green dyes absorb a mixture of blue and red. Red dyes. The color of the light is like complementary part of the spectrum to the color of the dye.
Oh, okay. I see what you're saying. So, red and green, and then blue and yellow, and so forth.
Yeah.
Okay. That makes sense. Well, we'll be just going to take a quick break, and I want to move on a little bit to what you've seen with cancer in our last segment. You're listening to HealthMade Radio. I'm here with Dr. Hamblin. Welcome back to HealthMade Radio. I'm Dr. Michael Karlfeldt. I'm here with Dr. Hamblin. So we were talking about photodynamic therapy, and we talked about infectious agents and how photosensitizers can be used, and what type that should be used, and depending on what light that you're using. Then when it comes to then cancer, you mentioned that there's been a huge surge of using then light in regards to people dealing with cancer. Are you allowed to say treating cancer, or how? I mean, where's the research in regards to cancer?
Yeah, so photodynamic therapy has been sort of established as a cancer treatment for quite a few years. This is using a exogenously administered dye, which is usually injected IV or topical preparation for skin cancers, for instance. So that virtually every dermatologist in the world will use PDT for various skin cancers. This is an established treatment now. So that is actually destroying a cancer. The cancer literally turns black, it's dead. You get like a necrotic area where the tumor used to be. And this is a medical procedure. It's carried out mainly in hospitals, but dermatologists do it in their office because they have a topical preparation and they have an LED light. That's not really a home use thing, although occasionally people claim to do it themselves. But I would not recommend it. So that's PDT. There are two applications of photobiomodulation. One is cancer therapy side effects, which is actually a big deal because oral mucositis, radiation dermatitis, peripheral neuropathy, these are horrendous side effects of cancer therapy. And there's no good standard treatment at all. And, a lot of people will stop the cancer therapy because they can't stand the side effects. And because photobiomodulation preserves and regenerates tissue, it's actually quite good for these cancer therapy side effects. Now, an emerging idea about light therapy in cancer is trying to stimulate the immune system. And there's PDT folks are taking an interest in stimulating the immune system, but it's very likely that just photobiomodulation itself stimulates the immune system. Now, people are worried that you could stimulate the growth of a cancer if you just shine light. This is with no photosensor, with light alone. People are a little worried that if you shine the light on the tumor, you could stimulate the growth. I think the jury's still out on whether that really does happen in patients. But, practitioners have been a little wary to treat people with cancer with photobiomodulation in case they make things worse. But undoubtedly, the cancer therapy side effect application is growing. And there's meetings all about this now, photobiomodulation for cancer therapy side effects.
So in regards to how it then would kill the cancer, when you say that the cancer using with skin cancer, and I would assume that there's a way to apply that science for more internal cancers as well. But how does it actually kill the cancer? Suggest that it creates that oxygen, reactive oxygen within the cancer and kills it that way?
Yeah, it also destroys the blood supply to the tumor. So you literally, because cancers have this neovasculature, these sort of imperfect network of capillaries, they're very sensitive to PDT. And you can shut down capillary blood supply to the tumor and literally starve it to death. And that's one mechanism, as I said, if you do it right, if you choose the right type of cancer and the right type of photosensitizer, it will literally turn into a little black dead thing. It'll literally shrivel up and die, pretty much.
Well, I mean, that's really exciting to be able to use something as harmless as light versus having to go with radiation or chemotherapy.
Yeah, I mean, if you inject the photosensitizer, you have to be a little concerned that people may have general photosensitivity. So for several protocols, they're advised to keep out of the sun for a few days or a week or something because, they could literally get sunburned from going outside. But that's pretty much the only side effect, because now you can deliver light to internal tumors. You literally do that by inserting through the skin very thin fiber optics. So you put needles through the skin, and you put very thin fiber optics through these needles. And the computer program can ensure that the light covers the entire internal volume of the tumor. It's the same way as we insert radioactive seeds with brachytherapy. It's the same principle, but what you're doing is you're inserting fiber optics, try and ensure the whole of the internal tumor is exposed to light.
And you would apply then an external photosensitizer prior to, you can apply that to the skin, or you have to inject it in the vicinity?
This is usually injected IV for this type of treatment. And the time between the injection and the light is closely regulated, depending on the photosensitizer. So there's a photosensitizer called TUCAD. There's a big trial for advanced prostate cancer, and that is a very short drug light interval. So the fibers were inserted through the perineum in the same way as they did for the brachytherapy, same principle. And this trial had hundreds of people in it, and it was a positive outcome. So this therapy is expected to be approved. Whether it's going to get US FDA approval, I'm not sure, but it's certainly going to be approved in other countries for sure.
Yeah. Well, I appreciate your time here on the show. You're such a wealth of information. I truly suggest all the listeners to look up Dr. Hamblin and all the research that he's done and how it's driving this science forward. Thank you so much, Dr. Hamblin, for taking the time with us.
Okay, well, thank you for taking the trouble to conduct the interview.
Absolutely, thank you. That is all for today. You're listening to HealthMade Radio. Make sure to check us out at healthmade.co.